Hi, everyone. I'm Eric from Mirantis, and I'd like to welcome you to today's webinar, Long Live Docker Swarm. Our speaker today is Jason Epstein, Senior Solutions Engineer at Mirantis. And in this session, Jason's going to introduce us to Swarm, explore how you should think about your options when you're considering both Swarm and Kubernetes, and discuss the future direction for Docker Swarm. Before we get started, we have a bit of housekeeping. We'll be answering questions at the end of the session, but you can submit those at any point in the question panel that you see pictured there, and we'll do our best to get to them in the Q&A segment. We'll also be sending out an email after the webinar with a link to the recording. So if you have to drop out or want to refer back to something Jason says, you'll be able to watch the recording afterward. That just about does it for housekeeping. I'll see you again during the Q&A segment at the end, but for now I'd like to pass the mic to Jason Epstein. Hi, Jason.
Hello, so I'm Jason Epstein. I'm a Senior Solutions Engineer at Mirantis, and one of the things I say is I consider myself a passionate containerist. So that means if I had my way, everything would run in a container. As Eric said, we're going to talk about Docker Swarm mode and all its benefits, and when you should use it. So as a dual orchestration company, we offer both Enterprise Swarm and Enterprise Kubernetes, and we'll get into a little bit about when you should use which. For this webinar, the focus is going to be on Swarm. We have lots of other webinars and publications on our website that are going to get into Kubernetes and how to leverage that orchestrator. So why don't we start with an agenda? So first, we'll do a brief intro to Docker Swarm, and then just to level set. And then we'll get into the first phase where you can begin with Swarm, and then we'll go into the next phase and discuss whether you should stick with Swarm or move to Kubernetes. And then we'll talk about the benefits of dual orchestration and the future of orchestration at Mirantis. And then we'll have a little bit of time at the end for questions. So first, let's move on to a brief intro to Docker Swarm, just to level set. So I would imagine that some of you are already pretty familiar with Swarm. And so the first part of this is just going to be a review. And maybe you're here just to better understand our position on Swarm and its future. And then others of you are really well versed in Kubernetes, but a little bit newer to Swarm. And then there's some of you who are just getting into containers and orchestration and just need a starting point. So the goal here is just to level set and help everyone out with whatever your goals are, and they're all worthy goals that we'll address in this talk. So let's start with what is Docker Swarm. So as you probably know, it's a container orchestration engine. Back in June of 2016, Docker began including Swarm as part of its container runtime. So if you wanted to orchestrate your containers, you didn't need to download and install a separate software package. It was already on your machine, and if you had Docker installed, all you need to do is turn Swarm on. It made it incredibly easy to spin up Swarm clusters and to begin orchestrating your containers. I'm going to show in my first demo how easy that is in just a couple minutes. So with it included in the Docker runtime, it also means it's included in the Mirantis container runtime, which we'll refer to as MCR, which takes a Docker engine and adds additional features and capabilities, including security hardening, to make it enterprise ready. As some of you know, this was formerly called the Docker Enterprise Engine. We now call it the Mirantis Container Runtime. So Swarm schedules your containers, sets up network partitions, monitors for container health, and will restart any containers that have died or are deemed to be unhealthy. If an entire node goes down, it'll reschedule those workloads on a different node. This is, of course, one of the most important jobs of a container orchestration engine. Also, Swarm works with both Linux and Windows worker nodes. In fact, it has supported Windows for over 5 years and has had time to iron out any kinks and optimize how it works on that OS. Lastly, Swarm can be extended with plugins for things like network, storage, and logging. So what does it actually solve? So it lets you declare your state instead of having to do everything manually, and all your resources, your services, any labeling or constraints can be declared in the YAML file up front. It also handles provisioning and manages where containers get deployed. So if you have a cluster of several nodes, it'll try to balance out your workloads across multiple nodes within your cluster. And that's great for high availability and scaling. So if you have a peak in traffic and need to scale up your web server, you can do that in Swarm mode. And then also, as I mentioned earlier, it'll move containers from one node to another. So if one node runs out of resources or the whole node goes down, that's when it'll act upon that. It also allows you to expose services with an ingress solution, and it also load balances traffic across multiple containers. And lastly, it keeps track of the health of those containers. So let's look a little bit about little into a high-level architectural view. First of all, in this diagram, we have 3 manager nodes. And those of you coming from a Kubernetes world will have a concept of master nodes. It's the same idea. Typically, you'll run your workloads on typically you don't run your workloads on your manager nodes or your master nodes in Kubernetes. And you always want to have an odd number of manager nodes. This is important for for voting for consensus when you have consistency issues on your managers. It's the same idea in Kubernetes. Now, if you have a development or test environment where availability is not a big concern, you can get by with 1 manager node. But in production, you'll generally have either 3 or 5. And the workers communicate with each other via the gossip protocol, and that's just kind of how they keep information synced. And as their name implies, as the worker node's name implies, these are nodes where actual workloads are run. So let's look at the breakdown of the 2 types of nodes. So when you spin up a service, you'll invoke the API. Well, in general, you'll invoke the API for the command line, or in the Mirantis world, your choice of the command line or the web GUI. And I'll show you that later in this presentation. And either way, a connection is made to the API of the manager node, which will then figure out what state you want versus what state already exists. So for instance, maybe you have 2 instances of your web server, could be Nginx or something else, but you want 3. So it'll reconcile that and figure out that it needs to spin up an additional instance. So the schedule will then find a node that has availability to run the new instance. It'll set up things like the IP addresses and the ingress piece and load balancing for these containers and dispatch this to the worker nodes that have availability. The worker nodes are responsible for running the workloads that the manager tells them and reporting on the health and status of the containers. And that's where the worker nodes execute on runtime come in. So as you can see, you don't really need to do anything to install Swarm. If you have Docker or MCR already running, all you need to do is enable Swarm mode. And I'll show you that in my demo in just a second. One of the nice things about Swarm is it already has built-in security. So TLS is on by default and handles the certificates. And you just turn it on by running Docker Swarm init. That's it. This makes that node into a manager node. And once this completes, it will then output the command you need to run on your worker nodes to have them join the cluster. So you'll run the provided command on any nodes you want to add to the cluster, and they will join it. The only requirements are that the container runtime, which could be Docker Engine or MCR, need to be already installed on the worker nodes, and they have to be able to reach the manager nodes over the network. As long as they can do that, they'll connect and join the cluster. So let's now show you a short demo where I'll do this. So first, I'll do a Docker Swarm init, and that's how you turn it on. And I'm gonna include the advertise address because this specific node, and this is a virtual machine on my local laptop. I'll also show you something on a real server using MKE. I am putting the advertise address in because it has more than one IP address. So I do that, and you can see it's now a manager. And if I do a Docker node ls, I can list the nodes, and there's only one node, which is the manager, and it gives me the command to use for joining a worker node. So I'll copy this command onto my worker node, which is over here. And if I put that in, it'll join as a worker. And now if I do a Docker node ls, I have both nodes. There's a manager and there's a worker in the cluster. And I've run 2 commands and I have a cluster running. So let's get back to the presentation. So now let's kind of talk a little bit about some of the concepts in Swarm, some of the objects. So first, so that's my demo. So let's talk about tasks. A task in Swarm is the most basic unit of scheduling. And for those of you who are familiar with Kubernetes, there's some resemblance to a pod. There's certainly differences, but it's the closest analog in the Swarm world. Basically, a task is a container and the commands that are run in it. And it's a small schedulable unit in Swarm. So Swarm manager nodes will assign a task to a worker node, and the worker nodes will run it and report on its status. So then a service, and that can include multiple tasks if you have more than one replica. So it's I think of it as being similar to the concept of a deployment or possibly a replica set in the Kubernetes world. And it specifies how many instances of a container to run. So the manager node will decide which node to run which tasks on. And the service will also include other parameters like resource constraints to determine which nodes a task can be run on. And that's kind of similar to the concepts of taints and tolerations in Kubernetes, and maybe things like the update strategy and the amount of resources they are allowed to consume. So now let's do a demo to see what this looks like in my environment, in my demo environment. So in this case, I'm going to create a service. So if I go back to my manager node, so this command, I'm going to create a service. The name is going to be Swarm Demo. There'll be 2 replicas, and it's going to publish it to port 8080. And it's going to run the Nginx image, which listens internally on port 80. And we run that, and it'll download the containers that it needs and set that up. And this is in host mode, which is different from mesh network, which you can also use in Swarm, and that allows you to get to a service by connecting to any of the nodes in Swarm. I'm deliberately doing this so I have to connect specifically to the node where my service is running. So anyway, this service has been set up, and I put in 2 replicas. And so if I do a Docker service ls, I can see I have 2 replicas and they're running. And if I do a Docker service PS Swarm, because I named it Swarm Demo, I have 2 replicas running. I set it up so one can run on the manager node. In production, you will want to not do that. In production, you'll want all of your services to run on worker nodes. So let's just test it out quickly. So the 192.168.33.11 is the IP address of my worker node, and that should be running this Nginx service now and it's externally exposed on port 8080. And here it is. If I have my HTML here that shows it. So let's go back here. So the last concept I want to cover is, what is a stack? So a stack is the next logical step as we continue to build more complex objects. So it's one of the services that form a complete application, and a stack can include, say, a few replicas of Nginx and maybe an instance of MySQL, and it's all assembled in a Docker Compose file. And it's a similar concept to a Kubernetes YAML file that could include multiple deployments and other resources and objects that you might need. So let's kind of quickly show you a demo of creating a stack. This time, though, I'm going to use the MKE web GUI. MKE, some of you know it as UCP. That's the former name. It's the same thing. And I already have, and this is going to be in Docker Compose file, Compose format. So I already have the GUI up. I already have it to this page where I can create a stack. And let's call this Jason Swarm Demo. And let's paste that here. And we'll see this is running 2 services. One is an instance of Nginx, and the other one is a Redis image. And I will create those, or create the stack, and it includes both services, and this will spin up. And now it's succeeded. And if I go to it, it's here, and I can look at the services that are running. There's my Redis, my Nginx, and these services are running. And it's a very simple example. In the real world, you're probably going to have compose files and stacks that are much more complex, but I just wanted to show you something simple for the purpose of this demo. So next, we want to talk a little bit about phases. So first of all, I think it's a good idea to begin with Swarm. Now, you might have some circumstances where it makes sense to do Kubernetes first, but in general, if you have to make a decision, I think it's, especially if you're new to orchestration or if you have a fairly small operations team, it's a good idea to begin with Swarm. Some of the advantages of Swarm, let's get into that, are you have very minimal effort in setting up your containers. And as I just showed you in my first couple demos, how it's really simple. Just one command to move into swarm mode, and then another command to join each node to the cluster. And it's also already included in our MKE product. So you're already, if you have MKE installed, you already have Swarm running. So next, the learning curve for both users and administrators is fairly small. You just saw how easy it was to deploy a service in a stack, and all the management complexity is handled by the product, not by you. So this gives your developers and operations folks more time to focus on building out your applications and ensuring they're running correctly in production, rather than wrestling with the orchestrator trying to make sure it's configured correctly. Swarm also gives you the shortest path to production-ready cloud-native deployments. That's right, with just a few simple steps, you're production ready. We'll cover later in this talk the fact that we have many large enterprises running their most critical production workloads on Docker Swarm. I believe some of these enterprises actually have folks who are tuning in for this webinar, so welcome. Lastly, Swarm is secure by default, and this is probably the biggest advantage. So Swarm automatically uses a layered network approach to reduce attack surface, and it helps ensure that only containers that should be able to communicate with each other can communicate with each other. Other orchestrators like Kubernetes default to giving you a flat network, so any container can talk to any other container if you leave the default settings in place. So next, who should be using Swarm? What's the ideal profile for a team or organization that would benefit from this? First, I would say developer-led organizations. If your focus is on running applications and getting them deployed, and you don't really want to do a ton of extra configuration to make sure they're production ready, nor do you want to deal with a steep learning curve, Swarm might be the right choice for you. Next, if you have a fairly small operations team, they'll find Docker Swarm to be the simpler of the two mainstream orchestrators for setting up and maintenance. A lot of the day one and day two operations will already be done for you, and it's just going to simplify your life. Then if your team is fairly new to container orchestration, Swarm is a good way to get started. But Swarm is useful far beyond the beginner stage. As you'll see later in this presentation, many very advanced enterprises are running Swarm in production because it just works. As long as Swarm meets your needs, use it. But know that we at Mirantis will support you either way. The last group of teams that are teams that need a quick way to deploy production-ready clusters at scale. So many teams don't want to put a ton of time and resources into deploying and maintaining their clusters. They found Kubernetes to be more time-consuming than they anticipated. So unless you require the advanced extensions and customizations that are only available in Kubernetes, you would do well sticking with Swarm. So next, we have to ask the question, should you use Swarm or Kubernetes? So let's start with what they have in common. So first, at a high level, both Swarm and Kubernetes have the concept of leader nodes. In Kubernetes, these are called master nodes. In Swarm, they're called manager nodes. Both require an odd number of nodes for the control plane to make voting decisions. If you're running a simple deployment where availability is not a concern, such as development or testing, as I said, one manager might be all you need. But for more critical clusters, especially in production, you generally want 3 or 5 nodes for the control plane. Next, let's just quickly review the architecture. Again, the most common production configuration uses 3 manager nodes, though sometimes 5, and you'll have your data store that stores the manager's state information. This is shared among all manager nodes, and the managers synchronize information between them. And then there are the worker nodes where the actual work is done, and they'll use gRPC for communication between managers and workers. In comparison, the Kubernetes architecture is almost the same. There's going to be some differences, and if we go deeper, we would see lots of differences. But at high level, they're very similar. So, for instance, one difference is the most common backend database is etcd, and instead of gRPC, it'll use HTTPS to communicate with the workers. But again, you have the concept of leader nodes, which are called master nodes in the Kubernetes world, and they also need to be in odd numbers for high availability. Again, all the work is performed by the worker nodes. So let's also review the components in the 2 types of Swarm nodes, the managers and the worker nodes. So first, the CLI interacts with the API of the manager nodes. This will handle authentication and authorization. It'll decide whether the required state matches the existing state, and if not, it'll reconcile it to determine what needs to be done. And then it allocates IP addresses to these tasks as each stack gets its own network partition. It then schedules these tasks, these nodes, and checks in on the health metrics to ensure everything is running smoothly. And the worker nodes are going to be constantly connecting to the manager nodes to send heartbeats, letting the manager nodes know they're doing fine and everything is running, and also responsible for executing what they're told to do. And they'll execute their assigned tasks and report back up to the manager nodes on the status of each health check. In comparison, the Kubernetes nodes have a pretty similar idea. Instead of the Docker command line, you'll use either kubectl, or if you're going to ask us at Mirantis, you'll use Lens. We of course have other webinars that'll delve into this tool. Either way, they communicate with the API server, which does the authentication and authorization. So the controller and manager will handle reconciling the desired state versus the existing state. And then it'll then decide what nodes to schedule the workloads on based on available resources and node requirements. So in Swarm, these were called constraints. In Kubernetes, this is usually done with taints and tolerations, and the state is stored in a backend KV store, which is usually etcd. On the worker node, it's the same idea as a Swarm worker node, except in this case, you have the kubelet, which will manage the node and make sure that all the pods that are supposed to be running are running. It'll check on the health of the containers and report to the manager node the status of and health data. And of course, the kubeproxy is going to handle the networking piece, and the runtime is going to be your container runtime. In the world of Mirantis, this will be MCR, which, as you know, is based on Docker with some improvements. So let's look at a chart that compares the two orchestrators side by side. So both orchestrators will manage your storage, networking, and ingress using YAML files. But the differences begin when we're talking about the learning curve. So in the case of Swarm, it's pretty easy for a newcomer to get started. And as you saw how easy it was in my demos to deploy an application, Kubernetes has a pretty steep learning curve. And I would even say for some scenarios, it might be overkill. Like for instance, I've actually seen customers that are running 1 or 2 applications in it with a very basic use case on a cluster that has 3 worker nodes, and they're using Kubernetes for this. And I don't have a problem with that. If they want to do that, that's great. But they probably would have had an easier time and accomplished what they need if they just used Swarm. Now, there's complexities beyond that. There's might be some other reasons why they need to be on Kubernetes beyond just these criteria. You know, for instance, if the organization has dictated every cluster needs to be on Kubernetes, or if they have a lineup of Kubernetes experts in-house, it might be a better choice. But all things being equal, this Swarm would have saved them time and effort. So the next piece is the CLI. So in the case of Swarm, you're just going to use the same Docker CLI that if you're coming from the Docker world, you already know and are familiar with. And then the compose format is going to be the same. Whereas Kubernetes has its own YAML format, and its CLI, which is usually kubectl, is going to be its own. It's going to be its own thing to learn. In Swarm, the basic objects are your tasks and services, and that describes the desired state. Kubernetes, not too different, but as you might know, a pod is a bit different from a task, but at a high level, it serves a similar function. And your deployments or even replica sets are going to be included as your basic deployment artifacts. So then Swarm gives you automatic application isolation with partitioning new tasks, or new stacks. Whereas Kubernetes out of the box gives you a flat network. So you'll need to do additional configuration or use third-party tools if you want to achieve the kind of isolation that Swarm gives you out of the box. Swarm has a really good, solid community of developers working on it constantly. But as you probably know, Kubernetes has a very large ecosystem of developers and third-party tools and plugins and products around that ecosystem. It's significantly larger, but both have an active community of developers and is growing every year. And then lastly, so in Swarm, a lot of your configuration is already in place. It's automated, and the hardware footprint is minimal. But one of the downsides is it's limited to what the Docker API can offer you. Whereas Kubernetes, you have the ability to add plugins and things like CRDs and extensions to really extend the orchestrator and customize it to exactly what you need and serve some more advanced use cases. So let's get back to the question. For your next phase, should you be using Swarm or Kubernetes? Well, I'm going to answer that with a non-answer and say, why not both? So this is kind of the Mirantis view. We offer a choice of orchestration technologies and give you the chance to go all Swarm or all Kubernetes, or what I really like is a hybrid approach. In that case, you have some clusters on Swarm because for those environments and workloads, that's all you need. And they can be in development or they can be in production or anywhere in between. And they're easy to set up, easy to maintain, and don't require a steep learning curve for your developers and operations teams. But then you have other clusters where you really need the extensibility that you get from Kubernetes. Maybe these are projects where you have a larger operations team running it, and they already have experience with Kubernetes. In those cases, you can run those clusters on Kubernetes. In the third scenario, you can even use both orchestrators in the same environment. You'll choose which applications are deployed to Swarm and which to Kubernetes. And this is what I call a mixed environment. So then dual orchestration. Let's see what this approach would look like. If you run the Mirantis orchestration layer, which is MKE, formerly called UCP, your worker nodes can be either Swarm or Kubernetes nodes. And if you want, they can even be both. Though generally we recommend every node be dedicated to either Swarm or Kubernetes and not a mix. The mix is really only recommended for like dev and test environments. But anyway, the points on the left give you some of the benefits. So first, MKE allows you to manage Swarm and Kubernetes clusters from just one interface. And as I'll show you in just a minute, you can easily move nodes between your Swarm and Kubernetes clusters. And then worker nodes can be Windows, Linux, or a combination, and both are supported under both orchestrators. And finally, you can use one UI, that's MKE, to deploy applications and services to either orchestrator. So again, Mirantis allows you to use both, just to recap, or use whatever orchestrator makes the most sense for you. Again, I like the hybrid approach where you use Swarm in some environments and Kubernetes in others, and in some cases you have a mixed environment. All these orchestration types can be managed from one UI. And since it's the same product and vendor, and for both, you can move applications from one orchestrator to the other and keep everything else intact. And of course, our services team can help you with any migrations you might need help with. And you'll still use the same support team for any of your support needs. We're there for you either way. So now I'll show you a demo of switching nodes between orchestrators. And I'm just going to give you the caveat that this is just moving your nodes from one orchestrator to another. Your workloads are going to stay with the orchestrator that they're on. So for instance, if I have a workload on Kubernetes and I'm running on a specific node and I move that node to Swarm, the scheduler will reschedule that workload onto another node that's running Kubernetes. And I'll show you that in the demo. If you wanted to migrate it from Kubernetes to Swarm or back, it's going to require some additional work. But you can do it yourself, or you can talk to our professional service team that has tons of experience doing that. That's your choice. So let's go to MKE. Okay, and as we saw, this is the stack that I deployed just a minute ago. And let's first look at let's pick on Nginx for a second. So if I click on this service, I can scroll down and I'm going to look at what node it's running on, and I want you to note that it is running on 172, 31, 45, 137. And that's a Swarm node. Okay. So now if I go to my nodes and find that, actually, let me go back to the stacks and look at the services. So this, actually, I'm going to use Redis. And we see this, I'm sorry, this is running on 23.193. So 23.193 is what I want. So here. So we can see this is a Swarm worker. And what I'm going to do is, so I have my Redis image running on this node under Swarm. So I'm going to change it to a Kubernetes node. And you see the note where it says Swarm workloads will be evicted. So I'm going to click Save, and this node is now being orchestrated by Kubernetes. So, as you might expect, that as we were warned, the service was evicted from that node, and it'll be moved over to a different node that is still on Swarm. And if we look back at the IP address, we can see this was a former IP address. It's been moved off of it, and now it's on this one, 172.31.39 to 133. But anyway, what I've shown you is that I can easily move nodes between Swarm and Kubernetes clusters, and it's just pretty easy. Okay. So now let's talk about the future of orchestration at Mirantis. So first of all, we're continuing to invest in both Swarm and Kubernetes. We'll have other webinars that'll get into what's coming in the future with a focus on Kubernetes use cases. But for Swarm, we have a dedicated team that just works on developing capabilities in that orchestrator. Coming up, we're adding CSI support, that's container storage interface support for cluster-wide volumes, along with chargebacks, which will work with both orchestrators. And that's going to allow you to track reserve CPU and memory at the container level, and then associate it with teams and users, etc. We're also going to be including a Swarm-only mode for MKE that will strip out the Kubernetes components so that it's optimized for Swarm. And we're going to make improvements to the interlock proxy as we continue to add features and capabilities. So if it's not already clear, we love our Swarm customers and we love our Kubernetes clusters, and we'll do whatever it takes to make you successful on whichever orchestrator you choose. Lastly, I want to talk a little bit about, as I promised, we have a number of high-profile customers running Swarm at scale and in production. So for instance, S&P Global is running it. MetLife is running Swarm. We also have several others in IT and the telecom space, including Splunk, HPE, and T-Mobile, and many, many more. Big name, large enterprise companies that are running Swarm at scale in production. And they found that, first of all, the day one and day two operations are pretty straightforward and easier to handle than other orchestrators. And they also find that it just works. It does what they need, and there's no reason to change. So just to kind of summarize, in some cases, Kubernetes will make more sense for you. And I don't want to discourage that. But in other cases, you're better off with Swarm. And it kind of depends on some of the criteria I discussed. And going forward, you'll continue to have these choices. As I said previously, I like the hybrid approach, but obviously your needs are going to vary depending on your unique organizational requirements.